So you shot this bear. You've gone from your hunting camp. You've walked 4 miles south. You turned due west and walked 6 miles due west. That's where you shot the bear. At this point, you realize you got to drag the bear back to camp. You realize you are still exactly 4 miles from camp. So here's my question. What color is the bear? Because according to the math we've learned, due south and due west are at right angles from each other, right? Which means this should be square root of 6 squared plus 4 squared, otherwise known as the square root of 52, which is like 7.2. You should be over 7 miles from camp. How can he still only be 4 miles? So this rule that we learned, that this distance here has to be, a squared plus b squared equals c squared, applies to what we call plane geometry. Now, plane does not mean regular or not fancy. Plane means flat. The world is not flat. Hills, yeah. But here's the thing. Even on the globe, it's approximately flat, except for one spot. There's actually 2 spots where this could happen, but since he went due south, that narrows it down to 1. If his camp, South Pole would be one of them, but he went due south. He can't go south from the South Pole. That would require a flight suit. But from the North Pole, if you go due south, then you turn and walk due west, no matter how far west you walk, you're still going to be that same distance from the North Pole. So what color was the bear? I love that problem because everybody gets locked into that a squared plus b squared equals c squared. The hypotenuse of a triangle has to be bigger than either of the legs. Yes, in plane geometry. And in our theoretical geometry world, everything is plane, it's flat. But in the real world, there are times where you have to take into that. For example, you ever hear the saying, the shortest distance between 2 points is a straight line? Which is great. It is true on a plane. On a flat piece of paper, if I want to get from here to here, the straighter that line is, the shorter it is. On a globe, if I want to get from here to here, guess what? That's the shortest distance. Why? Water. Not the water. Because the world is not a perfect ball. It's not a perfect sphere. Somewhat oval shaped. The equator, if you're looking at it from the side, it's much wider across the equator than it is from pole to pole. Think about it. If you take like a big ball of clay and you spin it, like the earth is spinning, actually quite fast, by the way. The earth is spinning, it eventually is going to kind of elongate, isn't it, because of the spinning. Same with the earth. The earth started out, it wasn't solid, it started out as a ball of gas and dust, and it solidified as it was spinning. Well, the spinning caused it to solidify slightly oval shaped rather than round, perfectly round. So it's technically an ellipsoid, not a sphere. In fact, the Earth is spinning at a rate around the equator. It's 15,000 miles, or about 25,000 kilometers around the equator. It does that in 24 hours. So it is spinning at over 1,000 kilometers per hour, or about 600 and some miles per hour. That the surface of the Earth is spinning at the equator. Yeah. Now, if you were standing at the North Pole, how fast would you be moving due to the Earth's rotation? Zero. You're not moving at all. You're just sitting there spinning. But you're not moving. You're not changing location. So at the equator, due to the Earth's rotation, you are moving, like I said, over 600 miles per hour. The closer you get to the equator, the slower you're moving. Not that you feel it. But if you want to get into, we're talking about geometric pole, axial pole. That's a very good point. There are two different things. There's something called the axial pole, which is, the axis that the Earth is spinning around. Then there's the magnetic north and south pole, which change constantly. They're always wandering, and they change. In fact, the geometric poles change slightly as well. The Earth does not sit there and spin, or not, the axial poles, I should say, change as well. The Earth does not sit there and perfectly spin on its axis. The axis actually slightly shifts through thousand-year cycles. But, that's why we have ice ages, and then 10,000 years later we have extremely hot periods. We talk about global climate change, and I'm not going to say that pollution and any of that stuff doesn't have something to do with it, because it does. But 65 million years ago, when dinosaurs walked the Earth, there's data that shows from the geological data shows that the average temperature is probably about 12 degrees hotter than it is now. And yet yeah, exactly. And about 12,000 years ago, where we're at right now is covered with glaciers. We were in the middle of an ice age. So there are natural temperature cycles too. We won't get into the whole idea of is there global warming and all that stuff, because, well, all I will say is the geological evidence is very, very vague. So anybody who claims to know for sure one way or the other is probably just pushing an agenda. But anyway, that's enough of our little fun excursion in math for the day. Let's talk about, did I ever give you guys the other extra credit problems? The father and son that was in a car accident?
Yeah, you did.
Did I give you that one? Okay.
Friday?
It was a couple weeks ago. It was like right after your, I don't remember what it was. I do remember doing it. The doctor was the surgeon?
Oh.
Okay, so we talked about variables yesterday and different uses of variables. And we talked about translating English into algebra, where you have something like 8 times the difference of a number and 2. What's that going to be if we write it out? There we go. It's 8 times the difference, which means the difference, which is the result of a subtraction problem, happens first. A number in 2 is x minus 2 or n minus 2 or whatever. That has to be in parentheses so that we subtract first and then multiply by the 8. Slightly different than this one. 8 times the number decreased by 2. How's that one going to look? Yeah, this one is 8 times the number, so it's 8 times x. Then subtract the 2. Could potentially be very, very different answers depending on the value of x. Here's a question for you. Is there a value of x where the two of those are equal? I'll let you think about that for a second. Is there ever a value of x where the two of those are equal? So anyway, today we're going to talk about evaluating expressions. And to evaluate expressions, we have to review order of operations. So if I have something like this, where would I start? You start parentheses, of course, and closing symbols are your first step. So you got this here, right? But inside that parentheses, you got to still look through the order of operations. Are there any other enclosing symbols? Yep, right here. Inside there, any other enclosing symbols? No. Any powers, exponents? No. Multiplication or division? No. All we have is subtraction, 9 minus 7, okay? Which is 2. Now I've reduced what's in that parentheses to a single number, so I don't need the parentheses anymore. I need to put in the multiplication at front, because that's 5 in front of the parentheses with no symbol, so I got to put multiplication in there. Nothing else changes. Now I'm working inside that bigger set of parentheses. In there, do I have any other enclosing symbols? No. Do I have any powers or roots? Yes, 2 squared, which is 4. So I'm going to take out the 2 squared and replace it with a 4. Any other powers or roots? No. Multiplication or division? Yes. Where do I start? 5 times 2, which is 10. What's next? 3 times 4 is 12. Then 12 divided by 6. Don't lose faith. You got it. Now we're done with all of our multiplication and division. What's next? We got to subtract. 16 minus 10 is 6. Plus 2, 8. So we reduced what's inside this parentheses to a single number. Don't need the parentheses anymore. What do we got to remember to add? Put in multiplication here. Now what? We got to do the multiplication. We've got to go left to right. We've got to do the 7 times 3 up here first. Then we can do 4 times 8, which is 32. Everything else stays the same. And then 4 times 2 is 8. And then 21 plus 32 is 53. Plus 8 is 61. Not so bad, huh? Try this one in your notes, see if you remember how to do it. So, where do I start? Well, the fraction bar means we start on top, right? And up top, what do we have to do first? 7 squared is 49, and then 5 times 3 is 15, and add to make 64. What's next? We gotta do the 3 to the third, which is 27, and then 28 minus 27 is 1, and then is 7. So we got 7 minus 1 is 6. 64 divided by 6 is 10 and 2/3. Good stuff. So the next step, similar to the order of operations, where the order of operations I would say simplify or find the value of. This one I would give you the command to evaluate. 9a plus 7b squared all over 3c. For a equals 12, b equals 6, and c equals 2. What this is telling me to do is two things. One, replace each letter with its assigned value. So instead of 9a, this becomes 9 times 12. Plus, instead of 7b squared, it's 7 times 6 squared. Over 3c becomes 3 times 2. And now it's an order of operations problem, just like the one we did. What's 9? Well, first the thing we have to do, of course, is the 6 squared, which is 36. Then 9 times 12, 108. 7 times 36, 252. 108 plus 252 is 360. On bottom, we have to multiply. 3 times 2 is 6, and then divide. You get 60. 360 divided by 6 is 60. Questions? Good deal. Remember our negatives? Remember how much you loved them? It's too long ago. The love affair has died down. It's just, it faded over time. Sorry. Sorry, integers, we've moved on. Now what? Well, this is going to be negative 2 times 7 plus negative 3 for D times the parentheses 4 times negative 5 squared. Notice I put the negative 5 in parentheses because on your calculator, most of you will have to do that or it'll screw you up. Minus P is 32. At least I didn't do subtract a negative. Plus 3 times negative 4. So 4 times, what's negative 5 squared? 25. Four times 5, 100, minus 32. 4 times negative 4, or 3 times negative 4, is negative 12. Now, we got to do 100 minus 32 is 68. Plus a negative 12 is so 56, right? Now I've reduced what's in the parentheses to just the 56. We don't need it anymore. So that's what we have. What do we have to do first there? Multiply negative 2 times 7 is minus 14. And then negative 3 times 56 is negative 168. Negative 14 plus a negative 168 is a negative 22. Remember those negatives fondly now? What if I were to give you 17 plus a negative 32? Remember how we did that? We did the vectors. Start at 0. 17 is positive. Negative 32 is the opposite direction because it's negative. Is it longer or shorter? Longer, so it goes into the negative. That tells us our answer is negative. And since they go opposite directions, it's the difference between 32 and 17, which is 15. So here, negative 18 plus 11. Here's 0, and negative 18 looks like this. Positive 11 goes the opposite direction. Longer or shorter? Shorter. So that's again telling us that we're on the negative side, and the arrows go opposite direction. So it's the difference between 18 and 11, which is 7. So negative 7. How about this one? What's that going to become? Here's 0, negative 42, positive 57 goes the other way, and it's slightly longer. So it's positive, and the difference between 42 and 57 is 15. What do you think? Better than a sharp stick in the eye? How about that one? But we're going to change this to negative 23 plus a negative 18. Remember, when we're working with integers, with negatives, we'd never subtract. Subtraction is the breeding ground for a lot of mistakes. So we just don't do it. We try to avoid it. Now that it's negative 23 plus negative 18, which is the same problem, here's negative 23, here's negative 18. We know our answer is negative, and it's just 23 combined with 18 is 41. How about this one? What's that going to become? Well, 27 plus a positive 14 minus a negative means you add the opposite. You're going to add a positive 14. So 27 plus 14 is 41. What's that one going to become? Well, negative 19 plus 32. Negative 19 plus 32 is a positive 13. You add the opposite of this, so it's going to become plus positive. Here, you add the opposites, it's plus a negative 18. Don't get in the habit of saying that, though, because there are times where it doesn't. Because, like, well, for like addition, negative 14 plus a negative 28, that's not going to look positive. But there's two negatives. So just be careful how you say it. When there's truth to that in certain situations, just make sure you know what situations it's true in. Yeah, this is going to be a negative 42.
It is fair because there's a positive already there, right?
Yeah. What's 11 times negative 8 then? Negative 88. How about negative 13 times a negative 4? Positive 72. Negative times negative is a positive. $36 divided by negative 9? Should be 52. You're right. I don't know where the 7 came from. No extra charge for extra time. Yes, negative 13 times negative 4 is a positive, but it should be 52, not 72. 36 divided by negative 9 is a negative 4. And 36 divided by 9 is 4. Positive divided by negative is a negative. When we're multiplying or dividing, remember, if there's one of each, it's going to be negative. If they're both positive or both negative, it's going to be positive. I think the best course of action would be just to have you guys practice for a while. In the little book, There's unit 31. Into the odds there again. In the big book, there might be a few more problems. Page 325. It's exercise 12-3, 1 through 17. Do the odds again. And page 213 through 215, 1 through 75, the odds. A little bit of review of your integers, your negatives.
Through 75. Woo.
Yeah, but I'm giving you like 17 minutes of work time. How often am I that nice to you?
Yeah.